We're going to talk about a given number as the root of p of x, the function of p of x. If you haven't seen the previous videos for chapter 11 and become lost or confused, there's links in this description. So we said in the last video, 11.2a, the remainder theorem is for a polynomial p of x, for the function of p of x, that function value p of r is the remainder when p of x is divided by x minus r. Now, since the zeros of a polynomial function are the roots of the corresponding equation, that was in 11.1a, we often refer to them as the roots of a polynomial. And using the remainder theorem and synthetic division, we can find p of r. So, if p of r equals 0, then r is a root of p of x. And we can determine whether negative 4 is a root of p of x, where we've got the function of p of x equals x to the third plus 8x squared plus 8x minus 32. We're going to use synthetic division and the remainder theorem to find the p of negative 4. So we put our negative 4 here, and we rewrite this expression without variables. So there's an invisible 1 in front of this x to the third, so we've got a 1. We use all the coefficients. We have an 8, we have another 8, and then we have a negative 32. We drop our 1 down, and then we say this negative 4 times the 1 gives us a negative 4. Then we add these. We get a positive 4. Then we do negative 4 times this 4 and get a negative 16. We add these and get a negative 8. That's our quotient. Then we do negative 4 times the negative 8 and get a positive 32. Well, that gives us a remainder of 0. And because p of negative 4 is 0, that number, negative 4, is a root of p of x. It made it a 0. See? Let's try another one. We're going to let the function of p of x equal x to the third plus 6x squared minus x minus 30. We're going to use synthetic division to determine whether 5 is a root of p of x. So we're going to rewrite this expression without any variables, only the coefficients. So we've got a 1 in front of this one and a 1 in front of that one, don't we? So we've got a 1, a 6, a 1, and a negative 30 for our synthetic division. We're going to use 5 to see if it's the root. We drop our 1 down, and we do 5 times 1. That's a 5. We do our addition, and we get 11. Now we do 5 times 11, which is 55. We do our addition and get 56. Here's our quotient. Then we do 5 times 56, which is 280, but a negative 30 plus 280 gives us a 250 remainder. So since the function of p of 5 is not equal to 0, that number 5 is not a root of p of x. So do you see what happens? When we had a remainder of 0, then that number in the that we were looking for to see if it was a root, it is a root. When we don't have a remainder of 0, then it's not a root. Okay? So the remainder theorem tells us that if p of r equals 0, then p of x has a remainder of 0 when divided by x minus r. And if the remainder is 0, then x minus r is a factor of p of x. And if x minus r is a factor of p of x, then r is a root of p of x. So this method can be used to find zeros of functions and to find roots of polynomials. All right? If you're really confused, you really need to watch those previous videos. All right? Now, our next video is going to be 11.2c. And we're going to talk about factors of polynomials. Is x minus r a factor of p of x? And we'll solve p of x equals 0. There's going to be a link to those 3 previous videos in this description, along with a link to 6.5 where we learned about synthetic division. I'm going to add this to the Algebra 2 playlist. And I hope you're having a great day. I hope this was helpful. And I hope I explained it well enough. Let me back up so you can see the whole board again. And we'll move on to our next topic, all right? I'll see you next video. Bye.